Right, so welcome everyone to this webinar on EI's Model Code of Safe Practice, Part 19, 4th edition, and Vulnerability Review and Assessment for Safety and Environmental Critical Equipment, 1st edition. So these two guidance documents were published earlier this year, and I will refer to the titles as EI 19 and SECe guidance going forward. My name is Laszlo Komarmi, Senior Technical Officer at the Energy Institute. I'll be joined by Paul Watkins from ENRG Consultants and Ian Herbert from Bulk and Hazard Management, and they will provide a high-level overview of each of these publications. So before I hand over to Paul and Ian, I would like to quickly cover a few housekeeping rules and introduce you to the EI and its technical work program. So the webinar is being recorded and will be made available on YouTube. All participants are muted except for the presenters. At the end, there will be a Q&A session. I would like to ask you to type your questions to the Q&A function during the presentations, rather than the chat function, because it will help us store the questions later. Also, when posting your question, please specify whether it is related to EI 19 or to SECe guidance by typing EI 19 or SECe followed by a question. So just a quick introduction to the EI and its technical and innovation program. So we are the Energy Institute, a chartered professional body for the global energy industry. Our aim is to create a better and safer future for both our members and wider society, and by accelerating the just transition to net zero. We do this by developing good practice guidance, providing professional training, and by facilitating open, collaborative dialogue with industry stakeholders. So our technical work is delivered through the EU technical and innovation committees that are made up of subject matter experts from member companies, regulators, trade associations, academic institutions, and others. We have more than 50 technical partners that fund our technical program, and we commission about 30 projects each year. These projects are authored by specialist consultants under the supervision of the committees. So we develop research and good practice guidance in a number of areas, including process safety and human factors, health, environment, but we also cover power systems, battery storage, hydrogen, onshore and offshore wind, and carbon capture, use and storage. Next slide, please. And next slide again. Yeah, so we also produce work on fuel quality, fuel measurement, distribution and handling, including aviation fuel, hydrogen, methanol, and ammonia. Next slide, please. Right, so here I've just handpicked a few EI publications related to fire and explosion hazard management that I thought might be of interest to you. So on the list, we've got guidance on fire and gas detection systems, guidance on selection and installation and management of fire-resistant sealants used in vertical secondary containment joints. We've got guidance on passive fire protection and guidance on assigning ignition probabilities, which can be used in quantitative risk assessment. But we've also got Model Code of Safe Practice Part 15, which is an area classification guidance, also known as EI 15. This is currently under review, and the new edition will be available in early 2024. So these are just a few examples. They can be found on the EI publishing website, along with other technical publications. And finally, just some useful links for you if you would like to learn more about the EI and its technical products, training courses, membership opportunities, and I've also included a link to EI's Toolbox platform, which is a free online resource that gives you access to learning from incidents and other safety information. So please check it out. So that's the EI in a nutshell. Over to you, Paul. Would you like to introduce yourself and tell us a bit about the fourth edition of EI 19?
Of course. Thank you, Laszlo. As Laszlo says, quick introduction. So my name's Paul Watkins, independent fire hazard management specialist with ENRG Consultants. And throughout my career, I've been assisting operators in a range of different operating environments, assess and implement their fire and explosion hazard management measures. Obviously, that in itself is quite a big part of the document we're going to discuss today, EI 19. With the EI, I've been involved in this capacity, this particular document, EI 19, really since its second edition, which when it replaced the old refining marketing safety code. And it's really grown as a document. We've added lots of things in recent years. Some of that's come about through incident experience, changes in standards and design codes and those sort of things. And Laszlo mentioned a document also that is about sealant materials for linear expansion joints in secondary containment walls. And I was involved in some of the fire testing and the authoring of that document. That's a good resource for anybody that's really looking at situations where they have to seal secondary containment bunds, perhaps the use of cover plates, that kind of thing. All of the sort of things that the PSLG post Bunsfield suggested would be good measures to put in place. So I'm going to talk today about EI 19, and as Laszlo said, it's a very high level overview of the document. Really, we're not going to be able to get into the minutiae of the provisions, but I'm going to give you a flavour of what it covers, the topics it covers, and how it can help you as an operator, or indeed somebody who's assessing facilities to look at and assess fire hazard management measures. And the important word on this slide really is monitoring the continued performance of those risk reduction measures, which generally speaking would be in many cases installation specific. And that's a very important thing, because it's all very well having the greatest sort of foam system or water spray system in the world, in terms of its design and such like, but if it's not maintained correctly, if it's not tested on a regular basis, not only that, if it's not designed with those sort of test facilities in place, then it can all fall apart. So I think EI 19 is not only giving you guidance on the selection of risk reduction measures, how to implement them, but how to think about how you want to maintain them as well. And actually, when we talk about risk reduction measures, we're not just talking about hardware items as well. We're talking about things like emergency response measures and procedural controls, perhaps, in terms of your overall fire and explosion hazard management. So central to the document is this concept of fire and explosion hazard management, or FEHM. And I'm going to come on to that in a moment in more detail with a little diagram, but essentially it covers a few things. First of all, it looks at fire scenario analysis, and it gives you some pointers on the sort of tools we can use to help you achieve that. It then helps you with various risk reduction measures. It gives information on things like incident prevention measures, incident detection systems, whether that's liquid leak detection or flammable gas detection and such like, and also quite a bit of information on the various fire protection systems that are available for you as an operator, or indeed if you're looking at those kind of things. It can be used. This process can be used to help you define and formalize your fire and explosion hazard management policy. So in other words, as an operator, it can help you, put that policy into place, to formalize it, and whether that sits in with the legislation in your particular operating environment, or whether it's something that's very installation specific, location specific. Going to the left hand side of this this diagram here, the first item is fire scenario analysis, and it's very important to do this as part of the FEHM approach. Obviously, there are a lot of tools, possible input tools we can use to do that, and they range from things like hazard and operability studies, HAZOPs, through to HAZIDs, hazard identification studies. We can use QRA techniques to help us analyze scenarios. Things like consequence modeling can be used later on down the line to sort of establish the potential consequences of incidents. But also incident experience as well, which is a very valuable tool in this process, because a lot of ways of dealing with incidents have come about through successful application of sort of fire response measures or systems and equipment that have been used to mitigate risks. So obviously, as part of the fire scenario analysis, we need to look at things like how can a loss of containment occur, where are the sources of ignition, what are the hazardous materials. And generally speaking, we would describe the incident and then think about the probability of an incident occurring and the consequences, in other words, a risk of an incident. If we could just go back to that slide briefly, Laszlo. Once we've looked at the fire scenarios, we can then think about the various risk reduction measures that we might have at our disposal. As I said, things like prevention measures, protection systems, both active and passive measures, and then things like response measures as well. As I say, we can then define the fire and explosion hazard management policy, which is relevant to our situation, our operating environment, our facility, and that will take into account lots of things, not only those risk reduction options, but how we actually implement them, whether we're likely to respond to incidents or whether we're likely to take a more of a sort of controlled view of things and let things run their natural course. So then we need to think about implementing those measures as part of our policy. And as I said a few moments ago, things like equipment maintenance, pre-planning, emergency response planning, exercising those pre-plans, and also training personnel become very important. Next slide, please, Laszlo. And there are lots of different guidance documents and sources of information that we can use, things like design codes and standards, but which we'll come on to in a moment. But generally speaking, when you're assessing a fire scenario and you're thinking about this fire explosion hazard management approach, you're looking at your fire scenarios in terms of loss of containment and potential for that loss of containment to be ignited. So we often see the bow tie diagram being used, which is the one on the right, of course, and all of those things on the left-hand side of the bow tie diagram, which are important, those important barriers that we can put in place, such as the incident prevention measures, are very important indeed. Looking at the diagram on the left-hand side here, as I said, generally speaking, you need a loss containment of flammable material. And in terms of tanks, that could occur through overfill, perhaps. And obviously, a barrier to overfill is having, for example, independent high-level alarms or automatic tank gauging systems and that kind of thing. In terms of ignition sources, that may be present, the two things combined to give a fire. We're thinking about things like, is there any hot work being carried out, and is that subject to permits? What about natural ignition sources, things like thunderstorms and such like? But generally speaking, we're trying to look at both sides of the equation. We're looking at prevention of the loss of containment, prevention of the ignition sources, and the ways in which we can achieve that. Next slide, Leslie. So to that end, the document EI19 gives us quite a bit of information on all of these barriers to loss of containment, barriers to ignition sources, and then further on it gives us information on the systems, the equipment, and the procedures that we can implement to mitigate risk. As I said, the document focuses on the selection, implementation of risk reduction measures, and it's important to recognise it's not a prescriptive document. The fire hazard management and fire explosion hazard management process really sets out good practice guidance and principles on options, on those risk reduction options, to assist people like process safety engineers, safety advisors, designers, and emergency responders and planners satisfy pertinent risk drivers within this sort of goal-setting framework that is generally being applied in many locations worldwide these days. So it's not prescriptive. The document isn't saying you have to put certain measures in place, but it's giving you the tools to assess whether those measures are good for your own situation. And if you consider that they are, then it's giving you guidance on how to implement them. So there are a number of sections on the different things. It starts off with sections on the control of flammables. So we talk about things like atmospheric monitoring, flammable vapor detection, flammable gas detection perhaps would be one of those things. Good ignition source control practices, including things like permit to work procedures, maintenance practices, good housekeeping, and also installation layout. So the installation layout is a particularly good example to think about when we look at storage tank facilities, where the tanks are designed, the layout of the tanks are designed, generally speaking, so that there are sufficient distance between tanks to prevent escalation. Now, of course, that's not always the case, and if it isn't the case, we then need to think about whether we can put measures in place to mitigate the risk of fire escalation between tanks. But installation layouts are a good example of. Well, there's a lot of good guidance on how we can think about laying out our facilities to avoid fire incident escalation. There is a lot of technical information in the document on various systems and equipment. On the incident detection side, we have some information on fire, liquid, and flammable gas detection devices and principles. And it's very much looking at the options that are available to you and the principles of detection. And of course, there are lots of different types of methods of detecting either flammable vapors or hydrocarbon liquids. A lot of new technologies exist. A lot of technologies that, although they've been used for a number of years now, things like acoustic gas detection are still in the process of being sort of proven worldwide over a large number of facilities. So, if you're thinking about whether you need flammable gas detection or hydrocarbon liquid leak detection, this document will give you a good starting point. It will give you an overview of the options that are available, and also the sort of key design criteria and key performance criteria that you might want to think about. And it's the same with protection systems. Generally speaking, we can have either passive or active systems. So passive systems being things like coatings or claddings that you might apply to pipe work or vessels that may be subject to fire conditions. And of course, active systems such as things like water spray systems, foam systems, dry chemical systems, that sort of thing. So in terms of the systems that are available and the various types which you see here, there's a lot of good information on the key design criteria for those systems, as well as explanations on how those systems work, the principles of operation, and the sort of things we need to be thinking about as either designers or people implementing those systems at their facilities. Now, one of the big types of systems, or the types of systems that everybody really is interested in, of course, as far as hydrocarbons are concerned, are foam systems. And whether you're at a facility which has lots of storage tanks, or you're at a facility where there are jetties, or you're dealing potentially with things like pool fires and spill fires, there's lots of information there on the types of system that are available. And again, key design criteria, things like application rates, foam system application rates, and so on. And it's important to point out that the information is not only valid for systems, i.e. fixed systems, which are bolted to the a tank or to some other location facility, but it's also giving you information on portable and mobile systems as well. So things like, for example, bund pourers or foam hand lines, and application rates for those sort of devices. Gaseous systems are covered also, whether it's local application or total flooding systems. Again, key design criteria, things to look out for, and also dry powder or dry chemical systems. As I said earlier, once those systems have been implemented, if you decide to implement them, then it's important that those systems are maintained and tested within a framework of what we call fire systems integrity assurance. So the document EI19 contains information on how to achieve that. Now, obviously, it's not just all about hardware, it's about response strategies, fire responders, taking into account, fire responders also includes operators as well as fire responders, and the options available to you for various incident types are outlined in EI19. So there's some really good information on the sort of procedures you might be thinking about in terms of incident response. Next slide, please, Laszlo. There's a lot of supporting guidance for the various risk reduction measures that are outlined in EI19. First of all, section on typical legislation and regulations, and obviously that just sets the scene, the context through which the risk reduction measures and assessment thereof should be looked at. So, whether that's the COMA regulations in the UK, the SECe principles, or the regulatory reform order, that kind of thing, when you're looking at fire risk assessments for the built environment. There's also a number of sections, or a number of annexes, if you like, on various topics, and some of these annexes are new, so it's important to know about those. The second and third editions included information on the fire-related hazards of petroleum and its products, so talking about fire classification according to the EI classification, and flashpoints and so on. But also now some information in there, actually I think this goes back to the third edition, on things like substances with a propensity to form vapor cloud explosions or result in vapor cloud explosions if ignited. And that really goes back to sort of the post-Buncefield time, when those substances were first identified. Now, if you're at a particular type of installation, you might have an installation which stores and processes, let's say, liquefied natural gas or liquefied petroleum gas, and you're wondering what kind of measures you can implement for fire hazard management, then you could refer to one of the annexes on the typical installations and areas fire and explosion hazard management. And that annex talks specifically about the measures that can be used for different types of facilities. Quite an important addition to the fourth edition this time around is an entirely new section on foam and the transition to PFAS-free or fluorine-free types of foam. And that particular section includes a lot of good information on developing performance-based specifications for foam. So if any of you, any operators are thinking about moving over to those foam types, and you're concerned about the performance of those foams and specifying them, then the annex includes some important information. Also, when you're designing systems, you might be concerned about the typical application rates that are valid for those systems, and not just systems, but portable and mobile application. And EI19 includes information on the suggested application rates to use for various situations. And it should be said that there may be situations where you need to run tests to find out whether an application rate is acceptable for your own situation or not, but it gives you a good indication of the sort of baseline application rates to use for things like cooling systems and foam systems. Some important sections also on emergency response team competence. So there are competency profiles included, and also some specific guidance on developing installation and scenario-specific emergency response plans, or SSERPs. I believe Ian's going to show a diagram of one of those in a few moments' time. But the document EI19 does include an example format that you might want to think about using for your facilities. It's not something you have to implement. It's not a format you have to use, but it's just something that you can consider for development at your own facility. There's also a section on notable refining and storage fire incidents, which is new, and this is in a tabular format. It lists a range of different incidents that have occurred over the years and gives some key information sources, including things like the CSB, databases of incidents. So if you're interested in particular incident types and how those incidents progressed and how they were dealt with, you can refer to that table, and you can go online, or you can seek out information on those incidents. Next slide. The key changes in the 4th edition. First of all, as I said, the document is there to provide you with guidance. It assumes that good industry practice is already being followed at a facility, but it will give you additional information, additional guidance that you might need to sort of make your fire and explosion hazard management policy more watertight, perhaps. There's an increased focus on environmental protection, so a lot of good information on PFAS-free foams, containment options, secondary and tertiary containment options, perhaps, and assessment of those. As I mentioned earlier, information on substances with propensity to form vapor cloud explosions. So a lot of the information that came out of the Process Safety Leadership Group post-Bunsfield is included. And also new technologies are available on things like fire consequence modeling, particularly things like computational fluid dynamics for explosion modeling. So if you're thinking about using that, or you're already involved in that, there are some key pointers on it. It's important to say there are also some local expectations as far as consequence modeling and scenario assessment. So we point those out in EI19. Things are different depending upon where you are in the world in terms of the criteria we apply, and EI19 recognises this. There's information also on things like crude oil boil-over scenarios, which has been expanded for this edition, and updates on various risk reduction measure technologies across the full FEHM spectrum, particularly in that area of incident detection, where realistically most of the sort of key technological advances have occurred. New information on scenario-specific emergency response plans, things like containment integrity, and things like looking at your the integrity of your secondary and tertiary containment options, with links to guidance including things like SECe 736. Next slide. So in summary, really the practical use of EI19, how do you use it to help you? You can use it to seek specific guidance on scenario development, risk reduction measures, or the FEHM, fire and explosion hazard management methodology. It gives you information on the key design guides, standards, approved codes of practice that can be used once you've selected your risk reduction measures. And they, of course, help you to design them and implement them. But really, EI19 sets out the methodology by which stakeholders, anybody who operates a facility or is involved with assessing facilities, can look at fire and explosion scenarios, compare those risk reduction measures, define their fire and explosion hazard management policies, and implement them. And of course, once that policy is implemented, you can use EI19 to maintain it. And that includes things like making sure your emergency response planning is up to date, that your competencies are correct, that life safety and environmental protection and fire systems integrity assurance are all addressed. I should say the focus really is on incident prevention at all times with EI19, but what we're saying really is if you need additional risk reduction measures to be implemented, if you require those, then you can learn more about those within the pages of EI19 and how to apply them. So really that's the sort of main practical use of EI19.
Yeah, thank you, Paul.
Thank you.
I think there was a lot to cover, and I think you've done a fantastic job. And so for those online, if you have any questions, this is a good time to pop them into the Q&A box, and we will try to answer them all at the end of the session. We might need to go over time a bit because of the technical difficulties we were experiencing at the beginning. So when you pop in your question, I see one coming through, which we will answer at the end. Please don't forget to type EI19 next to your question. And thank you again, Paul, and Ian, over to you.
Okay, thank you, Laszlo. Thank you, Paul. It's always difficult to follow on from such a good presentation. There's a good linkage in this. My name's Ian Herbert. I recognise a few names in the attendees list, so some of you probably know me as well. 38 years of experience in process safety, starting off with the nuclear industry, moving into ICI, was part of the ICI fire network in there, and later coordinated in within ABB, and most recently I was with MMI going through. Main part in leading into this is I was one of 3 expert witnesses on the civil case for Buncefield, along with Sam Mann and Mike Johnson going through. So we're pulled into that. So I had a lot of in-depth detail with the Buncefield case, and certainly the guidance notes that came out of that. So this is what it comes into this one. So without further ado, linking into this. So I've also been on the steering group for EI19, and I know Paul quite well. And linking onto that, so I've been involved with the EI19 development for quite some time as well, even not leading it. When I was with MMI, I was also one of the co-authors on the Passive Fire Protection Guide that Laszlo's already commented on going through. But to this piece of work, this is a piece of work that was started while I was in with MMI, and it was done as a bit of a joint effort, but I took the main lead on it going through. So I'm presenting this, but it was done in conjunction with MMI at the same time. But it's come around as a new guide in an attempt to answer a specific question that came out of the Buncefield Major Incident Investigation Board, which, believe it or not, is coming up for 18 years ago when Buncefield occurred. So we're still trying to get lessons out of it even 18 years on. But it was a specific recommendation that looks at the operators of Buncefield type sites, which were taken as being large atmospheric storage type sites, evaluating their siting or suitable protection for emergency response facilities such as the fire pumps and lagoons. So it was developed as a project to try and answer that particular aspect in general. It builds on previously some good information in the back end of Appendix 6 of the PSLG, which is the Process Safety Loss Prevention Group. That came out of Buncefield, a lot of good stuff in there, and this guide is trying to give you further pointers and developing areas to look at trying to identify these failures of emergency response systems. So next slide then, please, Alistair. So what we're looking at, following on from what Paul's mentioned, hopefully you've been doing your good FEHM studies, you've identified your fire hazards are going through, and you've got a large number of systems in there. So we're looking at the standard type of fire equipment, fire water pumps, lagoons, for water sources, deluge systems and other ones going through. But we're also looking at expanding it into other areas. It was not just the fire. Sometimes we're looking at the bunds that you've been used, because that's important for looking at pool fire type sizes, the detection cases, once you've had a loss of containment, access to those, and what exposed tank protection you might need, if any, to prevent escalation to those, such as from overpressure or fire spread. So it's the equipment generally in there, but it's also to include the interaction from operators in the operation of that equipment. So it includes the human interactions with those, with the operation of that needs to be considered as well. You might have all the best equipment in the world, but if you can't get the operator there to operate a deluge or to orientate your monitor correctly, it's not going to work going through. What's not being covered in this guide, and we're not looking at it, is not looking at the original losses of primary containment. So we're not looking at overfill protection primarily going through. But we are looking at what happens once you've had a loss of primary containment onwards. So we are looking at cases where it might be unignited LOPC, which could, in the worst case, lead to a large open flammable cloud explosion. That's another term that we've been using rather than just saying VCE, because the Buncefield case has shown that you can get some large overpressures and can get even deflagration to detonation transition in large open flammable clouds. So it's a bit of a subset of VCE, but we're looking at, again, the effects of unignited LOPC and then ignited LOPC scenarios. It's not been intended to look at pressurized storage, LNG, LPG type, other process operations, and bitumen and other lubricants, which might be heated storage tank type operations. It's just been primarily looking at the atmospheric storage tank case, see how that goes, and if the methodology the guidance helps, then maybe expand it into those other areas at a later date. So next slide then, please, Laszlo. We've used the term vulnerabilities to show failures of these safety critical equipment, and you'll notice from the title I've been using the small e at the end, because a large number of you will come across SECes in terms of safety critical elements, trying to keep it as distinguished and different from elements. This is equipment items. The main aim of the recommendation that we were trying to address was basically aimed at the sighting case caused by fire or explosion, thermal or overpressure. But these are just sighting failures with only one failure mode, that of survivability of the equipment to those events causing thermal or overpressures. There are other failures that can occur to these critical equipment items. We're using the FEHM type terminology. Again, people offshore will probably come across this and developing their performance standards, but it's the function of the equipment. Is it designed correctly to actually respond to the incident? So again, it's linking into what Paul's identifying in the FMAH in Program 19, is to test it to say, is it correctly designed? And I'll come on to this at a later stage in a bit more detail in a minute. The other ones are availability. Is it going to be reliable enough? And Paul again has alluded to, with this failure mechanism being maintenance, being a key one there, and reliability part of that as well. So availability, is it down? Have you got enough equipment items? And reliability, is it going to be working when you need it to? Survivability, which is the key aim in there, and interaction, which is the interaction of different equipment items. You might have fire detection linking in with automated shutdown systems and etc. But it's the interaction here is also interaction with human operators and interacting with the fire equipment as a key part as well. So next slide, please, Laszlo. So what we've actually done is I've grouped these into two parts. There's the survivability part, which is the key item which we're addressing against recommendation 12, and then we've looked at these other performance vulnerabilities: function, availability, reliability, interaction. And as I said, it's not just the physical equipment item, it's how we're actually interacting with it in terms of human failures. So that has certain failures that we can think of. Human failures and function is insufficient training, insufficient PPE, so they can't get to it, insufficient knowledge of emergency plans. Again, that's key from what Paul's been saying. Availability in terms of their numbers present and time to mobilize. You might have an emergency plan, but is it designed to be operating with a certain number of personnel on site and emergency responders? Will it work at 2 o'clock in the morning, etc.? There's an emergency case going through. And it's not just looking at your on-site personnel, it might be third third-party off-site emergency personnel as well. Reliability, can they be off sick? What do you do with that? What do you do if they're injured? In fighting the fires, thermal exhaustion can be a big case. Survivability, we'll come into this one, factors in there. They might not, you might be affected by the smoke and gases from a fire, not just the thermal or overpressure cases. So testing it on that. And interaction, the big one there usually is breakdown in communications and compatibility with equipment and fixed systems, particularly for you relying on external third parties coming in and tying into your emergency systems. Will it attach? They kind of come in with 2.5-inch hoses, and you've got 5-inch connections because you've been designing it for a large fire water system, incompatible, etc. So next slide then, please, Laszlo. So a lot of this is developed from different stages, is a key one. You're developing these equipment items from your fire and explosion hazard management systems, as outlined by the guidance being provided by Paul in EI 19. One of the cases was that the HSE focus, particularly in the PSLG, is largely based on the worst case. So they are panicking now about these large open flammable cloud explosions. But there can be earlier stages. It can be a single tank fire or a single bun fire, and then it escalates to a multiple bund and tank fire. A couple of cases that I can think of was Deer Park, was escalation of one tank to another, multiple tanks going through, or even back, if you remember, a Singapore incident with naphtha tanks, where you had an open floating rove tank that over the period of time spread from one tank to another. So large atmospheric storage tanks in particular can have last several days, can have multiple escalation routes, and they might have a number of what I call stable fire cases in that escalation path, that you might want to be having different levels of fire protection systems or emergency systems in there, at those different stages, and I'll show that in a bit more. And there may be other cases presented by the stored material. I mean, we've mentioned open flammable cloud, Buncefield type, VCE type, but that might be related to the stored materials. Not all materials will give you that large overpressure case, but you might have cases where you have a boil over as a bigger concern and escalation, and you might have then the difference between tank design, fixed roof versus floating roof. So you have different stages. So next slide, please. The guide has a number of sort of route maps that have been out in there to show how you can think about escalation at different stages, and then the concerns at each of the stages, because there may be survivability issues associated at different stages. You might also want to be thinking about equipment needs on site for responding to smaller single bun, single tank fire cases, which you'll be wanting to respond to as a sooner part of your incident planning, and then think about larger lost control of it. It's escalated to multiple tanks, multiple buns, and then you're getting the involvement of third parties, mutual aid groups, off-site emergency services, and what equipment do they need to be responding to those bigger incidents. So there's a lot of it in the guidance that trying to establish what equipment and testing the equipment you've got at different fire stages, particularly for atmospheric storage tanks, which have been known to burn for several days and escalate over that period of time. Okay, next slide then, please, Laszlo. This is the so the survivability criteria in terms of vulnerability often falls down into exposure to thermal cases and overpressure cases, and this is the image that Paul alluded to, being taken out of EI 19 as part of your scenario-specific emergency response planning. That can be used to give you your thermal contours, and you're looking then at whether you've got equipment that could be damaged within those contours. So it's no good having a deluge location or a monitor position from both the thermal exposure to the equipment damage, or also maybe a thermal hazard to personnel trying to access that equipment as well. So two parts of it, looking at these, there's a question looking at 4 hazard ranges. One is, can you get escalation from a fire and explosion case that means that you need to be thinking about equipment that you need for larger events from those escalation events, and can the equipment and the human interactions survive those. So we've got ignited liquids and vapors, which is giving you thermal contours. You've got overpressure and missiles from that. You've also got smoke and toxic cases affecting the human interaction or maybe operation of us on those. And basically the unignited, I've gone from the bottom up on this listing, unignited case, talked about EI15, an area classification. That's good for normal operations, but has it considered it for an accident or a large case? If you think again to Bunsfield, the possible ignition source was the firewater pump house. Now that was outside standard hazardous area classifications, but maybe there should be some consideration of where you place your gas detection. Maybe there should be gas detection at the entrance to firewater pump houses, maybe to isolate those or to stop those from operating for larger non-hazardous area rated type events or accident type events. So next slide then, please. How we're doing? I'm running over time. So that's the hazard ranges. So you're looking at it, can it be affected in terms of operation in those ranges, or performance failures going through? So performance failures, can it operate, or will it fail to operate in the set time? Again, thinking about your FASI cases. Survivability against the hazard ranges. Another survivability factor that we've got in the guidance now, and it's increasingly being important when employed and looked at, is survivability against NATEC considerations. NATEC is natural events cause a hazardous major accident hazard. It's basically, if you want to think of environmental factors, so things like earthquake, landslip, but in terms of the global warming ones, flooding, high winds, high solar events, etc., long dry periods. Bunsfield again was lucky because it occurred in the winter periods. One of the firewater ponds that it would often be called upon, it was reported often dried out in summer months. So have you got firewater sources in summer months, etc., or is it contaminated by sort of flooding events, etc., and other parts of it? So that's another survivability factor which is included in the guidance notes. Okay, next slide then, please, Laszlo. Moving it on. So once you've looked at these and we've said, are they acceptable or not, there's no basically a risk assessment case for looking at emergency response plans. It's usually up against acceptance against relevant good practice, for which you can look at the EI19 guide as a good starting point on that, and your emergency response plans developed through your fire and explosion hazard management. And this is being tested now by thinking the considerations within this guidance notes. So you're looking at, let's say, the performance failures, can these be resolved? Is it a maintenance issue that Paul's alluded to, or is it an availability issue or a reliability issue? We can pick up on that. Can those be resolved? Is it a design issue for the different stages? So, okay, the design might be good for early phase, but it might not be good for a multiple tank fire case. Do we need other systems then to support it? Survivability, typical one there is, can it be relocated or protected? We might be stuck with an existing site, so we can't relocate, but you could think about protecting some of those cases as well. If it can't, if you have got these failures and they're still existing, then determine whether those are critical, i.e. low chance that the equipment failure doesn't have much of an impact in terms of the overall escalation potential, or if it is critical, then maybe thinking about alternative equipment or emergency plans. And some of those emergency plans can be for atmospheric storage tanks up to and including let it burn. So you might think, oh, well, we can control certain number of fires, i.e. smaller ones, but for the larger, big events, all we're going to have to do is try and control it from getting any further and have a let burn policy. Okay, next slide then, please, Leslie. This is a bit of an extract from the guidance note, which goes through sort of how the guidance note tries to get you to think about these vulnerabilities on your identified emergency systems in there. So and it's pulled out in more detail in the guide, and the guide does have some examples in there going through. So that's pulling it through. So I've flown through the key points. So next slide, please. And I think that finishes me, Laszlo. So now I'll wait your questions that you may have on this, or go read the guide in conjunction with EI19.
Right. Well, thank you for a great presentation here. Got a question to I'll start with Paul. So this is about decontamination, PFAS decontamination, and existing firefighting systems. So it goes, do we already have good industrial practice recommendation for system cleanup and acceptance level of residual PFAS in the last rinse water? That's one for you, Paul. Oh. You're on mute.
Yep, Paul's on mute. Yeah.
Thanks, Laszlo. Yeah, I mean, if I've heard that correctly, is that thinking about the use of PFAS-containing foams and whether decontamination is considered in EI19? Is that right?
It's not specifically that. It's more about whether there is good industrial practice recommendation for system cleanup. Yeah. So yeah, actually, I think that refers to EI19.
Okay.
And I don't think we covered that in EI19.
Yeah, it certainly isn't covered in EI19 in a very high level of detail. I think really, as far as use of PFAS containing foams is concerned, and if people are looking to move towards fluorine-free types and so on, obviously you might have a situation where you need to decommission the foam that you've been using and dispose of it correctly and such like. Now, if it's being used and it's contaminated the environment in which you're operating, then for sure there'll be sources of industry guidance on that, and a lot of the sort of principles are really not covered in that level of detail in EI19. But obviously, if you're thinking about moving over to a non-PFAS containing foam or a fluorine-free foam, then obviously we're having to think about things like, in terms of decommissioning your existing systems, making sure the equipment is correctly sort of purged and cleaned and such like before you then put a new foam type in there. But I think there are a lot of ways, aren't there, of sort of getting rid of foams that contain PFAS. Whether that's if they've been used, whether it's things like reverse osmosis, or whether it's incineration, or granular activated carbon, those sort of techniques. So I guess in summary, those things aren't covered in detail in EI19, but there are, for sure, there are industry examples of their use and guidelines, but a lot of that will come from experience of the procedures that we used and such like. Yeah,
I think the key thing in EI19 on PFAS that Paul is also what you're replacing it with. Going through. There's a key part there. So
yeah, and there's a lot of good information in EI19 about how to develop your specifications for that. If you're thinking about a non PFAS containing foam or fluorine-free foam, right from very first principles, in terms of the type and application, through to testing it and maintaining systems with those newer types of foam.
I actually tried to find some guidance just a couple of weeks ago on this very same topic of decontamination, and I hadn't come across that. But it doesn't mean that there isn't any guidance. But
yeah,
certainly an interesting question.
Yeah, I mean, in terms of collecting foam that has been used, foam solution that's been used, and then dealing with it, it is quite a big undertaking, and there are only a limited number of techniques to use to dispose of it in a responsible, correct manner, you know, and they are expensive techniques. And only a few cases where those techniques have been used. So I think it's a case of, you know, seeing what has been done in the past. And there are quite a few operators around the world who've had to do this. And I think it's all about getting that information from those operators and seeing what worked and what didn't.
Right.
Okay, all right.
Thank you.
Next two questions I'll take then, Laszlo.
Right.
So we got a question from Jaco Van Latone going through. Does the SECe guidance include anything about fixed semi-foam system piping and support fireproofing, if reasonable at all? The guidance does contain a list of typical typical emergency critical systems, which includes foam systems, etc. It doesn't go into specifics on, you know, what you should do in protecting those, but you can think about it. It contains within the guidance notes, particularly on the hazard ranges, typical some outline guidance on exposure to different thermal levels and overpressure cases, which might cause physical, i.e. survivability type losses and vulnerability on systems to be considered. So there is bits in there. So there is a list of, so summaries, there is a list of appropriate systems that you might see, so you can use that as a bit of a test on your emergency planning. And then there is some guidance on typical overpressures and thermal cases that you might see that might cause damage or failure of those systems to perform as required, i.e. as a vulnerability to those. And therefore you might want to be thinking about protection, such as fireproofing from a thermal case. If you can't relocate it to somewhere or make it strong enough, you can be picking that certainly in that side of it. So yeah, it's a general guidance note. It's not getting into specifics at all there. It's trying to get people to think about these vulnerabilities. And the second question you came up with was asking about hazard range for boil over. Definitely does have some information on that. Again, it's typical ones. You might want to be modeling boil over in a different way, but there is some outline guidance on differences for boil over distances, typical what's being typically picked up to give you as a starter for 10 in one to try and identify those hazards in there. So that not just for that boil over, but also, as I said, for thermal cases, for even exposure to smoke and gas, etc., what to be considering about that as a hazard range, and its vulnerability to people and equipment is in the guidance note. I see Steve's now questioning, going through, do you support a zone 3 approach, ignition source controls for those distances outside traditional zone exempt for customer events? Yeah, I can see where you're coming from on that going through. I certainly think that is a case. Traditional zone 0, 1, 2 cases are for normal and anticipated failures of equipment, expected cases. You can, as it's been shown in the past, you can get what I call catastrophic or accidental releases that go well beyond the typical hazard ranges that are out there. For zone 2, say, equipment, it doesn't. And I would look at trying to think of, is there a potential for a major catastrophic loss of containment that could give us a more of an off-site case, typical for Buncefield and atmospheric storage, of big overfill, large case of fairly high vapor pressure materials, such as the listed materials, which can give us a vapor cloud of a large open flammable cloud explosion material. So using the PSLG type materials in there, maybe if you've got some of those being held, think about these catastrophic type zonings. And think about what you've got equipment in there. I would think, and again, I think this part's in the guidance, say, right, if you've got those potential accidental low likelihood events that could give you hazard ranges beyond the normal hazard ranges, think about having gas detection on your site and maybe at these potential off-site ignition sources that may be linked in then to a a shutdown of your energy sources, so prevents the pumps running, prevents the pumps tripping, or other energy sources that trips them out, if it sees gas detection on the site and gas detection, say, at the possible ignition source case. I mean, again, even so, the Buncefield was an obvious one. It's occurred in the Caribbean case. I forget what the name of the site was. I think it was Puerto Rico going through, Caribbean oil going through, which was again similar to Buncefield, large ongoing release. It found ignition sources further afield. In India, you had the Jaipur case. Again, these are two very similar cases to Buncefield that occurred not long after Buncefield. Within a couple of years of Buncefield, we've had these cases where you've had these big releases of these open flammable cloud materials that have been ignited and caused these big flammable cloud cases. I've often come across the case of saying, would a site for atmospheric storage tanks be better if we had a load of pilot flames all round it? So whatever release you had, it just gets ignited as a small pool or jet flame, because we've gone into all this effort to try and control our ignition sources closer to the site. It's a bit of a silly argument going through, but what we should be looking at is making sure that we've got means to detect these releases, the smaller releases, and then possibly thinking about, as Steve's put forward, a zone 3 approach for materials that could give us a big catastrophic case that gives us a lower likelihood flammable cloud that goes beyond our typical hazardous areas, and maybe thinking about ignition source control for those incidents. I've rambled there quite a lot. I hope that answers your questions. Any other questions? Have we got some more?
I haven't got any other questions.
No, so thank you. That's right. Yeah.
Yeah, and also Steve is seems to be very satisfied with your question, so with your answer. So I think we are 13 minutes over, so I think we should probably stop there. So there are no more questions.